So it sounds like there's a couple different challenges then for this entire new space economy, right? You touched on the kind of limited carrying capacity, the limited space in space,
Hmm.
and then maybe also you can touch a little bit further on the space debris because I think this is something that doesn't really get that much attention. I don't think. I've read a couple articles back when I had Asgard Space on.
Hmm.
Our mutual contact, and there was I think some crazy number, like several million pieces of space debris from like a single. I think it was like a single paint speck, right? All the way to one of these larger decommissioned satellites that are still just kind of floating around, not really doing anything other than taking up space and potentially causing some kind of collisions. Could you touch on that a little bit more? Because I think it's quite interesting, especially as you've kind of painted this vision of kind of an exponential growth of satellites and other kind of technologies that'll be taking up our limited space.
Yeah. So, how do we know space orbital debris exists? So there's a U.S. started something called Space Surveillance Network back in the day, and today it's a combination of Earth radars and telescopes and on orbit assets and laser ranging tools. The initial purpose of this network was to detect ballistic missiles, but as a byproduct
Hmm.
of that, we started seeing objects in orbit. And then what has the way it's evolved, and it continues to evolve. It is scanning Earth orbit for all the pieces that it can see. So right now we can see using Space SSN, we can see objects that are larger than 10 centimeters in diameter.
Okay.
So U.S. Space Force, used to be U.S. Air Force, now U.S. Space Force, catalogs somewhere between 20 to 30,000 objects that we can see. So these are
Okay.
objects that they could be natural debris, or they could be man-made debris. That, as you said, it can be just a piece of paint that came off of a launch vehicle, or it can be a second stage that we left in orbit, or a decommissioned satellite. Now, it's estimated that there are about 1 million pieces of debris in Earth orbit.
Hmm.
And that's the estimate because we can't see anything smaller than
Right.
10 centimeters
Right.
diameter. Now, a new radar came online, I believe, last year called Space Fence that is operated by SSN that is capable of seeing much smaller objects, about 3 centimeters and large. It's expected that once this radar's data is ingested into the catalog, we'll be able to see over 100,000 objects. So the
Mm.
reality is, the
Mm.
more we look, the more we find.
Yeah.
Now, these objects. So just to you know, so these objects are flying at 20,000 miles an
Yeah.
hour. That's about 10 to 17 times the speed of a bullet. Now, at that speed, if a fragment size of a penny, if it hits a satellite, it will destroy it into pieces. And when that happens, if that happens,
Hmm.
it doesn't just end that particular mission. The debris from that collision, that can be in thousands of pieces, will stay in orbit for tens or hundreds of years. And each one of those become another piece of debris that would
Yeah.
threaten
Yeah.
assets. So it's not, Gravity movie came out, right? So that is actually based on true science. Kessler syndrome was introduced by Kessler in 1970s. And it's a chain reaction. So if you have one collision, the debris from that hits other assets, destroys
Hmm.
those, and
Hmm.
it causes a chain reaction that can basically make an entire orbit unusable for generations.
Yeah.
So it is an extremely difficult problem. And again, as I mentioned, even if we stop launching a single satellite today, we still have to deal with this growing pain of, hey, we have all these collisions that we have to avoid. And it happens on a daily basis. Satellite operators perform maneuvers to avoid collisions with other operational satellites or orbital debris on an ongoing basis.
Yeah.
And it gets
Yeah.
worse. Sorry to interrupt you.
Yeah.
And
No,
it gets
no.
worse because when you have an asset that you can maneuver, it's easier because you don't even maneuver it out of the way. But when you have two objects that are not maneuverable, and then they're at risk of colliding, there's nothing you can do, and that's the worst case scenario, which we had one of them a couple of months ago when two giant pieces of debris got very close together. So when we talk
Mm.
about um, things like the latest Chinese rocket body that was left in orbit that came down a few days ago. That's a big problem because you have 20 plus tons of material. And if that
Right.
20
Right.
ton, object collides with another object, it will create so many pieces of debris that can create a cascading effect for other operators. And it's not about just the and it's not just about the satellites that are currently in orbit. If you try to launch anything into space, you got to
Yeah.
go through the lower Earth orbit. So one of the products that, for example, we have is called launch conjunction assessment. When you're launching a new launch vehicle, you want to make sure that from first stage, second stage, payload, all of the other components are not going to collide with anything.
Right.
And it was in the news that in April, when the Dragon was docking with ISS, they had a turned out to be a false alarm, which is, again, underscores the story. But they had to get back into their suits because they thought that there was a close approach with a piece of debris. So it's
Right.
threatening not just satellites, but human life, and also any kind of mission, whether it's Earth bound or Moon or Mars or beyond. You have to go through this cloud of debris to get out.